In an earlier video, we focused on the arithmetic sequence. In this video, we're going to focus on geometric sequences, but we are going to have some questions involving arithmetic sequences. Go through the problems or show you the problems. You can pause the video. You're given some sequences here. Some are geometric, some are arithmetic, some are neither. So you are to identify what they are, and if it applies, to find the common difference or the common ratio. So you can try these and then I'll be back. So just to remind you, for the arithmetic sequence, we're given the terms, in this case 2, 5, 8, 11. So sometimes you'll be given the actual terms, sometimes they'll give you a formula, as in this particular video here. A1 is the first term, second term is 5, third term is 8, next one's 11, and so on. And you can see that every time here we're adding 3. 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, and so on. So we can identify the first term as 2, and the common difference is 3. That's what we're adding to get the next one. And then of course, sometimes you talk about the series of these terms. And you have formulas for finding the sum of the first n terms and so forth of an arithmetic sequence. Now for the geometric, you might be given the terms this way. So for the arithmetic sequence, you're adding the same number to the previous number to get the next one. For the geometric, you're multiplying. You can see here, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so on. So this is a geometric sequence. The first term is 2, and the common ratio, denoted by R, is equal to 2. If you take the quotient of any two terms, 4 over 2, consecutive terms, 8 over 4, 16 over 8, it's always going to be the common ratio. So if that's the case, it's geometric. And then we'll look at these formulas. We won't really use these today, but in this video, but here's the formulas for the geometric sequence. First term is A1 is denoted sometimes by A, and then the nth term divided by the A sub n minus 1 term, or the previous term, same thing, saying the previous term, is equal to R. And this is the recursive representation of a geometric sequence. Write it this way, or you can write it as A sub n is equal to the common ratio times the preceding term, A sub n minus 1, where R is not 0. This is the number A1 is the first term, and the number R is called the common ratio. And same thing we had with the arithmetic. We can find the nth term using this formula. A sub n, or the nth term of the geometric sequence, will always be the first term times R to the n minus 1, where n is the nth term. R cannot be 0. And then you have a formula for the sum of the first n terms. You can denote it by a summation here, k equal 1 to n of A1, and then times R to the k minus 1, which simplifies to this formula right here. R does not equal to 0 or 1. Now you can also have infinite. This one goes from 1 to n. That's a finite series. In this case, we're adding the terms. Sometimes this will go to infinity, and there's a formula for that, which is given by this. If the absolute value of R is less than 1, the infinite geometric series, okay, now we're talking about a sum, converges. That means it adds up to something. It doesn't get larger and larger or smaller and smaller. Its sum is finite or approaches a finite number denoted by A1, A sub 1 over 1 minus R. So we're going to use these formulas in the next video. But for this one here, we're going to stay very basic, just to introduce the concept here. So again, determine if a given sequence is arithmetic, geometric, or neither. If applicable, give the common difference / or common ratio, depending on what it is. So now this one gives it to you as a formula. So you can just go ahead and say, well, let's try this. Let's find the first term. Put 1 where the n is. 1 and 2 is 3. Put a 2. We get 4. Put a 3. Put a 3, we get a 5. And the pattern continues. So it should be clear that in this case we're adding 1 to a first term to get the next one. 3 and 1 is 4, 4 and 1 is 5, and so on. So this is a arithmetic sequence, and the common difference is 1. Arithmetic sequence, common difference is 1. Okay, for B, it's 4n squared, so we can just pick values. Put 1 where the n is, we get 4. Put a 2, 2 squared, 4 times 4 is 16. And put a 3, where the n is, 3 squared is 9, times 4 is 36. And the pattern continues here. So first we see if it's arithmetic. To get from 4 to 16, we have to add 12. And then it has to be consistent. So if I add 12 to the 16, I have to get 36. I don't. So it's not arithmetic. Now for a geometric, you can just take the quotient of successive terms. So 16 over 4 is 4. And then 36 over 16 is not 4. So it's not geometric. This one would be neither. Now you try the next one. You put a 1 where the n is. So a 1 squared is 1 times 5, and 1 is 6. 2 squared, put a 2 there. It's 4 times 5, 20, and 1 is 21. Then put a 3. 3 times 3 squared is 9, times 5 is 45, and 1 is 46. And you're just doing that just to figure out what the pattern is. Okay, well you can see from 6 to 21, it's not the same as from 21 to 46. In other words, I take the difference between 21 and 6 is not the same as 46 and 21. So it's not arithmetic. It's not arithmetic. It is not geometric because if I take 21 over 6, that's not the same thing as 46 over 21. So this one, again, is neither. For the next one, let's put a 1 where the n is. So that's going to give me, let me just do it up here, 3 minus 2/3. And then compute this out. So let's multiply by 3 here to get the same denominator. That would be a 9 over 3. So 9 thirds minus 2/3 is 7 thirds. Then put a 2 where the n is. So this will be 3 minus 4 thirds. And then again, combine this. It'll be 9, 3 times 3 here, and 3 here. That'd be 9 over 3. That'd be 5 thirds. I put a 3 there, so this will be 3. The 3's will cancel out here. It'll be 3 minus 2 is 1. So I should get the same thing if I subtract the terms here. So let's do this. 5/3 minus 7/3 is a minus 2/3. 1 minus 5/3. 1 can be written as 3/3, so 3/3 minus 5/3 is a negative 2/3. So I got the same thing. So this one is arithmetic, and the common difference is negative 2/3. Here this. For the next one, 2/3 to the nth power. So put a 1, we get 2/3. Put a 2 there, and so you can see the pattern. I'm just going to go ahead and put it as 2/3 to the second. Put a 3, I get the next term, so it'll be 2 to the third. And so on. So you can see here I get 2/3 and then 2/3 squared and then 2/3 to the third. So from the first term to get the next one, I multiply by 2/3. To get the next one, I multiply by 2/3. So this one is geometric. And the common ratio. Geometric, common ratio 2/3. By the way, you can see that if I take any two terms and subtract them, I don't get the same thing. So it's not arithmetic. Is it geometric? Well, let's see, minus 2 over negative 1 is 2. Negative 4 over negative 2 is 2. Negative 8 over negative 4 is 2. So this one is geometric. And the common ratio is 2. And then G, we have 1, 1, 2, 3, 5, 8, and the pattern continues. And you say, okay, you can see if I subtract consecutive terms, 1 minus 1 is 0, 3 minus 2 is 1, 5 minus 3 is 2. I don't get the same thing. So it's not arithmetic. If I take the ratio of consecutive terms, 1 over 1 is 1, 2 over 1 is 2, 3 over 2 is 3/2. If I take the ratio of consecutive terms, I don't get the same thing back. It's not geometric. So this one is neither. This one's neither. However, this is an important sequence. It's just another type of sequence. It's not geometric and it's not arithmetic. This is called a Fibonacci sequence. And the rule for this one is after the first two terms, to get the third, you add the previous two. Notice the pattern. 1 and 1 is 2. Notice 1 and 2 is 3. 2 and 3 is 5. 3 and 5 is 8. Okay, it's a Fibonacci. But here we're asking about arithmetic and geometric. Okay, then in the next one, we give it the sequence there. So when the formula then is 3 to the n over 2, this will give you the list of the terms. So put a 1 where the n is, and this will be 1/2. Put a 2 where the n is. 2's cancel out, I get 3. Put a 3 where the n is, and I get 3 to 3/2. And then with 3 terms, we could go ahead and test it out. If I subtract consecutive terms, 3 subtract 3 to the 1/2 is not the same thing as 3 to the 3/2 minus 3. So it's not arithmetic. Well, let's do this then. Let's find, test it to see if it's geometric. Take 3 divided by 3 to the 1/2. So this is a 1 here, so Using your basic laws of exponents, we have 1, bring down the base, subtract the exponent, so 1 minus a half is 1/2. For the next one, 3 to 3/2 over 3. Bring down the base, which is 3, and we subtract the exponent, so this will be 3/2. So 3/2 minus 1 multiplied by 2 here, by 2, so 3/2 minus 2 over 2 will give me 3 to the 1/2. So I did get the same thing back. So this one is geometric, and the common ratio is 3 to the 1/2. Thanks for watching. We'll see you next time.